Okay, so this is 7th grade 8.3.1 and it's titled What is an Angle? So we are skipping through quite a bit of CPM so that we can get through concepts that we need to know before 7th grade is over. Alright, so what is an angle? Have you ever watched a dance team performing a routine in which each person moves and spins in perfect unison? So that means all perfectly together. Each dancer always knows exactly how many times to turn and the direction in which he or she should end up facing. In this lesson, you'll develop several ways to describe turns by investigating angles and look at angles inside of shapes. So we're going to start with 851, and it's called My Head is Spinning. And this is actually what we kind of did in the Google Meet a couple hours ago. So it says, what does it mean to do a 360? What about a 180? Part A, it says your teacher will instruct you to stand up and do a 360. That is to turn 360 degrees. So I'm just going to do it right here. And Abby did it this morning on the Google Meet. So she spun all the way around until she was facing front again. So that's a whole 360. Then if you do a 180, I remember Abby turned and then faced this way. So that would be a 180 degree turn. So it's half of a 360. So that's kind of demo. We did a demo. B, it says to work to design a clear and consistent way to draw diagrams to represent these movements. Be sure your diagrams include something that shows the direction a person would face at the beginning and at the end of the turn, as well as the size of the turn in between. So I drew some silly little pictures. So here's what I drew first for a 360. So I drew a circle like this with an arrow, and this means the person turned all the way around and is now looking the same direction again. So that was a 360. So that would be my little diagram. You can draw yours differently, but that's what I did. And then for the 180, I did the same thing. I did a little stick figure, and then the 180, I did it like this, because it's half of a 360. And then the person is now facing that way. So the person has their back towards you now. So that would be the 180. Okay, so part C says, what would it mean to do a 90 or to turn 90 degrees? What about a 45? So now it says to add diagrams for those. So I'm going to draw for a 90 degree. I drew my person first like this. And then for 90, I did, what did I do? I went like this. So that's 90. And the person now faces to the side. So the person went like this, and now they're like this. So that's a 90. And now it says to do a 45. So same thing, person like this. This is a little bit harder to draw, but I did a 45 like that. Oops. And then the person is facing a little bit, yeah, see, it's kind of hard. But it would be like this. It would be kind of like a diagonal that way. Not all the way to the side, but right in the middle. So here is 0 degrees, 45 degrees, 90 degrees. Okay, that's part uno. That's 851, sorry. 852. If you have a printer, you can print this out, but I will show you this next part with my resource page. Okay, so 360 refers to turning in a full circle, turning completely around, right back to where you started. The most common unit used to measure rotation is a degree, and there are 360 degrees in one full rotation. I forgot to print this one out. That's okay. So now in your book, it says to get a copy of this resource page, which it's just right in your book. So it shows you the diagram, so you don't really need the resource page. And it wants you to estimate. I'm going to try and bring the computer to you. Wants you to estimate. Let me see if this is working. Yeah. Estimate, is that it? Let me see. Yep. Wants us to estimate that angle measurement. So I'm looking at it and I notice it's a pretty acute angle. It has to be less than 90, obviously. And it even looks like it would be less than 45, because 45 would probably be in the middle right there. So I estimate about 20 degrees. So I put an estimate at 20 degrees for that one, and we'll check to see if we were correct later. Okay, so 852, 20 degree estimate. Okay, so now 853, it says angle rulers. How can you measure angles accurately using degrees? In this activity, you will build a device, but I'll build it since you guys don't have it, called an angle ruler to help you measure angles in degrees. So here is what the resource page looks like. It was a circle, but it wasn't folded and it didn't have any of my markings, but it was just a circle, and it has the 180 to 0. And it says to find a way to fold and label the resource page multiple times to make it into an angle ruler. So the ruler starts with 0 degrees and then includes a mark for 180. Design your angle ruler so that you can measure common angles such as 30 degrees, 45 degrees, 60 degrees, 90 degrees, and 135 degrees. So I folded this in half first to show my little 180, and then I folded it in half again, and I put 90 degrees as this angle. So this angle would be 90 degrees. And then I folded it in half again. All right, I'm gonna continue it out here because my dad had to take a call, but you'll see that I folded it in half. We got the 90, folded it in half again, and you get the 45. And then I was like, well, how could we get a 30 degrees and a 60 degrees? And I actually folded this little pizza slice. So this guy, I folded it in thirds, and I got the 30 degrees right there, and then I got the 60 degrees. So then I made a little dash for 15 just in case, so you'll see that 15 is quite small. So this is my full half circle, and then 135, obviously. So you'll notice that these are the smaller angles, these are all the smaller ones, and then these become the bigger ones, right? These are the obtuse. So this, I also cut it in half and knew that 135 is halfway between 180 and 90. And then I cut it into thirds again. Mine's not exactly accurate with the 165 right here, but if you cut it into thirds, you'll also get the, you'll get 120 and then 150 and so on. So that, and then if you bring it out, you'll see it does become a full circle, and you'd be able to mark all the degrees up until 360 to make a whole circle. All right, so it wants us now, I printed out the resource page from earlier, so now it wants us for 854, I believe, to use our new angle ruler, that's what they're calling this, to measure out that angle we estimated. So if I try to line up the dot with the dot below it, let me see, I'm gonna do my best. And then we need to line up that 0 degree with that line, and it looks like that line is about 20 degrees, maybe 20, 25, but I think we were pretty close on the estimate there. So that's pretty cool. Let me see if it's, yeah, I think that's about 20 degrees. So that's how you could use your little angle ruler, your circle, to measure your angles. Now let's go back to the book. So we did 854. So I put the new measurement tools pretty accurate, and it says for 855 that actually angle rulers do exist, and they're called protractors. So it says to get a protractor from your teacher and compare it with the one you made. And I actually, bring it back over here, I printed out a protractor from Google, and it's pretty, okay, so we're going to compare the angle ruler and the protractor. So some similarities that I see is that there's that little circle there, and there's a circle right there, and I'm assuming that's where we line up our 0 degree line when we're measuring an angle. It's got measurements up at the top. However, the difference is that we have the whole circle, but a protractor is half the circle. So I'm noticing there's not just one number at each dash, there's 2. So I see a 10 here, but I also see a 170. I see a 20 here, but also a 160. So that means that you could either, the angle you're measuring could either be an acute angle, so it could either be 30 facing like this, so that would be your angle right here. So that would be a 30-degree angle. But if you're measuring it like this is the angle, obviously that would be a lot bigger, and that's the 150. So it depends on what direction the angle is facing, but that would be the main difference I see. And there's also a nice little ruler attached to it. All right, so now it's saying for 855B, Hunter needs a protractor to measure the angle at right. He got 60 degrees, so this angle right here. Is the answer reasonable, and explain why or why not? So I'm gonna look at that angle, and it looks bigger than 90, because 90 would be a perpendicular line, and with this horizontal one, so that would be 90. This looks bigger, so there's no way that could be 60 degrees, so it is not reasonable. It should be bigger than 90 degrees. And then part C says, when measuring an angle with a protractor, it's necessary to line up one side of the angle with the 0. Oh, is it necessary to line up one side of the angle with the 0 degree or 180 mark? If you did not, how would you figure out what the measure of the angle was? So let me go get my protractor and show what would happen here. Okay, so if I have my protractor and I'm lining it up with my little circle there, and then the horizontal line matches up there. So that looks to be about a 110 degree angle. So that would be 110, and it says, is it necessary to line up one side with 0 degrees or 180 degrees? So if I lined it up like this, say I did this for some reason, and you would take, whoa, sorry, I'm trying to do this with one hand. So you would take this measurement, which would be about 40, and this measurement, which would be about 140 or 150, and subtract them. And then you'd get your angle measure. So that's if you're not lining up the line like this, which I recommend lining up the line, which just makes your life easier. Okay, I think that's it, because 855 was our last problem. So that is going to be, let me just double check that that's our last problem. Oh no, we have to do 856. Okay, so 856 says, estimate the angles formed in the diagrams below without measuring. So we're not even using anything to measure. Explain your estimates. So let's look at A. A looks bigger than 90, and it looks maybe like halfway in between 90 and 180. So I would estimate that's probably 135. So B looks, it's an acute angle, so it's smaller than 90 degrees. And it looks like it's kind of halfway maybe between 0 and 90, if 90 was over here. Yeah, that looks good. So that would be half of 90, 45 degrees, my estimate. C, I know that's 180, so that's 180 degrees because it's a straight line. And then this one's very small acute angle, so it's even smaller than this one, and we said that was 45. That kind of looks like the one we did earlier, so I'm going to say about 20 degree. That looks like a 20 degree angle to me. All right, if you'd like some more practice, you can keep going on, but they aren't required. 856 is our last problem, okay? And I will see you in the next lesson.